Hello students, in this lecture we are going to discuss the concept of momentum and Newton's second law of motion. Fine. So starting with the concept of momentum. Fine. Now what is momentum? Fine. Momentum is the product of mass and velocity. Fine. So momentum is equals to mass into velocity. Momentum is denoted by symbol p, small p, that is equals to m into v. Clear? So momentum is mass into velocity. Now look at this relation that momentum is directly proportional to the mass and momentum is also directly proportional to the velocity. Means if you increase the mass of the object, then momentum will increase. If you increase the velocity of the object, then also the momentum will increase. Clear? So now look, the formula of momentum is mass into velocity. Mass is a scalar quantity and velocity is a vector quantity, which makes momentum a vector quantity. Clear? So momentum is a vector quantity. Clear? Now using these two terms, fine, if you want to plot a graph between momentum and mass, momentum and velocity, in this graph we will keep the velocity constant. Fine, we will keep velocity constant. Fine, we are not changing the velocity. Now if you increase the mass, then the momentum will increase like this. Fine, if we don't change the velocity of the body, with increase in mass the momentum of the body increases. Fine, but in the case of momentum and velocity, if you keep the mass constant, fine, same, velocity is the momentum is directly proportional to the velocity, means when you increase the velocity the momentum will increase. Same, if you increase the velocity then the momentum will increase, because momentum is directly proportional to the mass and velocity. Clear? Now let us discuss the SI unit of momentum. Now the formula of momentum is, that is mass into velocity. The SI unit of mass is kilogram. The SI unit of velocity is meter per second. So the SI unit of momentum becomes kilogram meter per second. Clear? Let us understand the concept of momentum with an example. Suppose we have two balls, a tennis ball and a cricket ball. Fine, we know that the mass of cricket ball is more, means mass of cricket ball is greater, but the mass of tennis ball is less as compared to the cricket ball. Fine, suppose these two balls are moving with same velocity, means the velocity is constant in this case. Fine, so if you have constant velocity for both the balls, we know that the mass of cricket ball is greater, so by the formula momentum is equals to mass into velocity, the momentum of the cricket ball is greater as compared to the tennis ball. Fine, so we need more force to stop a cricket ball as compared to the tennis ball. So we can say the momentum is actually the quantity of motion of an object. Clear? Now let us discuss the Newton's second law of motion. Fine, Newton's second law of motion states that the rate of change of momentum is directly proportional to the external applied force. Fine. It states that the rate of change of momentum is directly proportional to the external applied force. Clear? Means force is directly proportional to the rate of change in momentum. Means change in momentum per unit time. Rate of change of momentum is directly proportional to the force applied. Clear? Suppose you have a body, fine, whose mass is m, fine. Initially, it is moving with velocity u. Clear? Some force applies on this body, let F be the force. Now, the velocity of the body becomes v. Mass is m and the velocity of the body becomes v after time t. Clear? I'm repeating again. Suppose a body which has mass m is moving initially with velocity u. Force is applied on this object and the final velocity becomes v. Clear? Now, the initial momentum means P1 is equals to mass into initial velocity. Mass into velocity is the momentum. So, mass into initial velocity becomes initial momentum. Second is final momentum, means P2, that is m into v. M is mass and v is the final velocity. Fine. Now, according to the law, we have F is directly proportional to P2 minus P1 upon T. Fine. The value of P2 is mv minus the value of P1 is m into u upon T as it is. Fine. Now, F is directly proportional to m common, it becomes v minus u upon T. Now, look at this. We have the formula of acceleration, that is v minus u upon T. Now, put the value of this acceleration in this equation. Now, F is directly proportional to m into a. Fine. Now, F is directly proportional to mass and acceleration, means F depends on mass and acceleration. Remember one thing, whenever we need to convert proportionality into equality, means proportional sign to equal sign, proportionality to equality, we need to use a constant, a proportionality constant. Here, the proportionality constant is k. Clear? The value of k is 1. So, F becomes m into a. So, here is the formula of force, that is the product of mass and acceleration. Clear? So, you can write force is equals to mass into acceleration. Clear? Now, the SI unit of force. SI unit of force. According to the formula, F is equals to ma. The SI unit of mass is kilogram. For acceleration, it is meter per second square. Fine. Kilogram meter per second square is also called Newton. So, the SI unit of force is Newton, denoted by capital N. Clear? Now, I am repeating again. Newton's second law states that rate of change of momentum is directly proportional to external applied force. Fine. F is directly proportional to P2 minus P1 upon T. Initial momentum is m into u, final is m into v. Put these values in the equation. We have F is equals to m into v minus u upon t. Change in velocity upon time becomes acceleration. So proportionality constant becomes k, the value of k is 1, so F becomes m into A. The SI unit of force is Newton, which is equals to kilogram meter per second square. Clear? Thank you. Hello students. In this lecture, we are going to discuss some applications of Newton's second law of motion. Fine. As we know that force is equals to rate of change in momentum according to Newton's second law of motion. Fine. So from this relation, we have that force is inversely proportional to the time. Inversely proportional to the time means if you increase the time of impact, then the force will decrease. Clear? I am repeating again. If you increase the time, then the force will decrease, as we have relation F is equals to P2 minus P1 upon T, means F is inversely proportional to the time. Inversely proportional means if time increases, then force will decrease. Now let us discuss the first application of Newton's second law of motion. First application is a fielder while catching a ball pulls his hands backward. Fine. When the fielder pulls his hand backward, in that case the time increases. Fine. While catching a ball, fielder pulls his hand to increase the time. If the time increases, then the force of impact decreases. Fine. So in that case, fielder hurts less. Fine. Now the second application is automobiles are fitted with shockers to reduce jerks. Fine. So automobiles are fitted with shockers. The purpose of the shockers is to increase the time of impact of the jerk so that the force of jerk experienced by the passenger sitting on the vehicle is less. Clear? Now the third point, the third application. In a high jump athletic event, the athletes are made to fall on cushioned mattress. Fine. So the third application is in a high jump athletic event, the athletes are made to fall on cushioned mattress. Fine. When an athlete falls on the mattress after his high jump, the mattress is slowly pressed downwards, which increases the time of impact, hence the force decreases. Fine. The fourth application is a person falling from a height on a hard cemented floor gets injured but does not get injured on grassy or on a heap of sand. Fine. So the application is a person falling from a height on a hard cemented floor gets injured but does not get injured on grassy or on a heap of sand. Fine. If the person falls on the heap of sand or on the grassy surface, the time of impact increases. Hence, the force decreases. That's why he does not get injured. But on the cemented floor, the time is very less. The time of impact is very less, so the force increases. So the person gets injured. Clear? The fifth application is electronic items or crockery or the chinaware are wrapped with bubbled polymer sheet or packed in thermocol boxes. Fine. So the fifth application is electronic items, crockery or the chinawares are wrapped with bubbled polymer sheets or packed in thermocol boxes. Fine. If these items are mishandled, the time of impact increases due to the soft nature of thermocol boxes. As a result, the force of impact decreases. Fine. Due to this reason, the glasswares, crockery or the chinawares, they are packed in thermocol boxes. Clear? Now, the sixth application. When a fast moving train collides with a stationary train, huge damage is caused to the moving train. Fine. When a fast moving train collides with the stationary train, huge damage is caused to the moving train. Fine. As the result of collision, the moving train suddenly comes to rest and the rate of change of momentum of the moving train is extremely large. Fine. As the result of this, force of impact on the moving train is extremely large, which causes a huge damage of moving train. Clear? Which causes a huge damage to the moving train. Fine. These are some applications of Newton's second law of motion. I am repeating again. We have the formula F is equals to P2 minus P1 upon T, means force is equals to rate of change in momentum. If you increase the time of impact, then the force will decrease because force is inversely proportional to the time. In the first application, we have discussed a fielder while catching a ball pulls his hand backward to increase the time of impact and to decrease the force. Second, shockers are provided in the vehicles to increase the time of impact again. In a high jump athletic event, athletes are made to fall on cushion mattress. Cushion mattress, the purpose of this cushion mattress is to increase the time of impact and to decrease the force. Fine. Similarly, a person falling from a height on a hard cemented floor gets injured because the time of impact is very less in the case of cemented floor, so the force increases. Clear? All the crockery, chinawares and the electronic items, they are wrapped or packed in thermocol sheets, fine, or thermocol boxes to increase the time of impact. Fine. Sixth application is when a fast moving train collides with stationary train, a huge damage is caused to the moving train. Fine, because the time of impact is very less. Fine, so in that case the force increases. So these are some applications of Newton's second law of motion. Clear? Thank you.